Alright, welcome to another fun edition of my notes that will help you hopefully do better in my class. So, what are we doing here now? What are we going to do? We are going to work on a test review, getting ready for the next test, which you will be taking soon. So, let's look at some problems. Okay, so what do I have to do for the first step? Here are a couple of problems that we can work off of. I need to add 17 first to both sides, and then I can divide that answer by 5. So that one's fairly simple. You add or subtract, and then you divide. And usually that's a lot of what you do here. If you look at the next problem, you need to multiply by 3. So you get 21x minus 3 equals plus 5 equals negative 52. Then most of the time what we did was we combined the two numbers, 5 and negative 3, to get a 2. And then from there you can subtract 2. I made a mistake there. Oops, fixed it. And then you can divide by 21. Why am I writing negative 21? I have no idea. So let's fix that and say we're going to divide by 21x is equal to negative 54. So divide by 21. And then you can simplify that fraction, or you can give me the decimal answer depending on what calculator you're using. So it would be negative 18 over 7. Okay, so for the test, I'll probably, like I said, this test is going to be I'm going to try to bring it down to about 12, 13 problems, so maybe I choose one of these two problems, but we'll see either way. Keep in mind that there's an equal sign here that divides the x's, so with this type of problem, I always say variables to the left gives me 5x, and numbers to the right, that gives me plus 12, negative 45, and then I can divide. And keep in mind, when there's no absolute value, you only get one answer. If there was an absolute value, that's when you can get two answers. Here, notice that this is on the same side, so and then I'm just saying what's 9 minus 5x. So 9 minus 5x gives me 4x minus 19. And then I can move the 19 over here and say plus 19. I have no idea why I wrote it like that. To get 40. And then I can divide by 4 to get x equals 10. So you can see here slightly different answer, or slightly different methods to solve these, but keep in mind like which side they're on. And that should help you with that. Okay, number 5, notice that this is an absolute value by itself. There is nothing on the outside of that absolute value. Nothing here, and it's equal to a negative number. If you have an absolute value equal to a negative number, that is no solution, which you can show as NS or with a 0 with a slash through it. Here I'm saying, okay, this is equal to a positive number, so I'm going to say 5x plus 2 equals 37. 5x plus 2 equals negative 37. Okay, and then the steps should be the same. So I can subtract 2. You get 5x equals 35. And then divide by 5. You got x equals negative, I'm sorry, why am I saying negative? X equals 7. Here you got negative 39. 5x equals that. Divide by 5, and you get a fraction, x equals negative 39 over 5. If you're using a decimal, I believe that would be about 7.8. Negative 7.8. Trying to do that in my head, so I'm not positive there. But anyways, there you go. Those are your two answers, and you are done. Okay, so that should be easy. Now, how is that different than number 7 when I say 2, absolute value of 3x minus 5, absolute value of negative 58? The safest method to do is to go ahead and isolate the absolute value, which means this is times 2, divide by 2. You get 3x minus 5 equals 29. And then I can split that to be 3x minus 5 equals 29, and 3x minus 5 equals negative 29. So I'm going to add 5 to both sides to get 34 here, and divide by 3 and get x equals 34 over 3, or about 11.3. Okay, or I'm going to add 5 here. Notice the steps stay the same. You get 3x equals negative 24. So divide by 3, and you get x equals negative 8. And that's that. So that's about as hard as those get. Okay, so here you can see the answers for these two problems. Basically, all I did was I plugged in the numbers and then I carried out the multiplication and then took the absolute value. Keep in mind that if you're just doing the absolute value and there's nothing on the outside, you will get a positive answer. So do all of this and then change the answer to a positive. Because like on this one here, number 9, you would have got a negative 40. Obviously the absolute value of negative 40 is positive 40. So keep that in mind. That should hopefully help you with that. Alright, so what do I need to do here? Okay, notice this one has a left, a right, and a middle. Okay, work from the middle. So I'm going to add 20 to both sides. Working from the middle. That gives me 3y in the middle. I've got 12. I don't know where I was about to write negative 12 here. And over here I have 272. Then I can divide by 3 and get 4y, and let's see, 72 divided by 3 would be 2 times 24. Okay, so that means here what I would do, and y'all have a number line that worked there. Now some of them got a little bit off because maybe I messed up or whatever, like just the formatting with the computer was not working. But you have a 4 here, you have a 24 here, and these are in-betweens. These are ands. Okay, that means I'm going to shade in between. Close dot there because of the line, open dot there because of that one, no line, and you shade in between. There you go. Number 11 is an or. So that means technically they should go in opposite directions. Although it is possible, especially since I chose these problems randomly from the book, that they might go in opposite, they might be like in the same direction. Now I will make sure that tomorrow they go in opposite directions, so kind of keep that in mind. So here I'm solving basically two different problems at once. This is 15x minus 6 less than 24. Add 6 to both sides. You got 30. 15x minus or less than 30. Divide by 15. X is less than 2. I'm getting ahead of myself there, but you got the idea. Or here, this one's a variables on both sides. It's probably way more difficult than I would choose, but I'm going to move the 5x to the left, minus 5x. I'm going to add 4 to the right, plus 4. I get x greater than 6 minus 1 is just 1x, 8, and so x is greater than 8. Absolute value. Okay, so here's 2, open dot, shade to the right. Here's 8, open dot, shade to the left. Shade to the left, shade to the right. The 2 is shade to the left, the 8 is shade to the right. And that's what I expect from most of my AND statements. Now, for bonus, both of these, if you give this to me in interval notation also, if you add in interval notation, so like here, 4 to 24, and on this one, negative infinity to 2, parentheses 8 to positive infinity, and I will give you a bonus, like bonus points. Like I will give you 1 or 2 points extra for each problem that you do that like correctly. Alright, so let's look at number 12. 2x minus 3 greater than 15, or 3 minus 7x less than 17. Okay. So I'm going to add 3 to both sides here, divide by 2, x greater than 9. Or 3 minus 7x, I'm going to subtract 3, get 14, then divide by negative 7. When you divide by negative, that switches the inequality, so that now is a greater than negative 2. So this is an example of one that I probably would not do because they're both going in the same direction. So you would have something that looks like this. Here's negative 2, here's 9. This one is open dot, well this one is open dot, goes this way. This one's open dot going the same way. So notice how it runs over that. So really, if you look at your interval notation, because this is an or, so that means I take either one, which is negative 2 to positive infinity. That's the interval notation because this one right here gets run over by the other one, so it just runs it over and that's it. Again, something I will more likely avoid. 13, why didn't I have more with the ands? Oh, they did that and. Okay, I will always keep them in between, so don't worry about that. So 15 minus 5x less than or equal to 0, and 5x plus 6 greater than or equal to negative 14. So here I'm going to subtract 15, divide by negative 5, x, remember they switch, 3, and minus 6, 5x, oh that's a negative 14, sorry, negative 20, and then divide by 5, x greater than or equal to negative 4. Okay, so basically this is an and one, so here's negative 4, here's 3, close dot at both. Which one do I care? Okay, and cares about where they overlap. So you can see here they're only overlapping starting here, so that's your answer. So that means this answer is 3 bracket comma infinity. This is the only answer that counts right here. Again, I will make sure the ands are in betweens and the ors are separate directions. That's just something that happened in this review. That's what I get for copying random problems from the book. I always got to avoid that. All right, start with number 14. Absolute value of 2w greater than or equal to 5. All right, so this is a greater. That means it's 2w greater than or equal to 5 or 2w less than or equal to negative 5. Notice how I set that up. So that means divide by 2. You get w greater than equal to 5 halves, or w is less than or equal to negative 5 halves. So that would look like something like this. Negative 5 halves, positive 5 halves, close dot, shade this way, close dot, shade that way. And that's really all you got to do. Interval notation would say negative infinity to negative 5 halves, bracket, positive infinity, bracket, positive 5 halves, positive infinity, parentheses, and there you go. Again, that's for bonus points. You don't have to worry about it too much. All right, number 15. Absolute value of y plus 5 less than 2. So this is a less than, remember, less than, so that means it's got to be in between. So you're saying y plus 5 less than 2 and greater than negative 2. It's going to be between negative 2 and 2. So less than is an and, so it's between. So that means I can subtract 5 from off the left, the right, and the middle, whatever, however you want to think of that. Cancels. Y is going to be between negative 7 and negative 3. Shing. Negative 7, negative 3, shing, and shade in between. So negative 7, interval notation, negative 3, parentheses. Number 16. X minus 8 greater than or equal to 3. So again, x minus 8 greater 3, or x minus 8 less than or equal to negative 3. Add 8 to both sides. Dot, 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 dot. You get x greater than or equal to 11 or x less than or equal to 5. So again, here's 5. Notice that the smaller number is always on the left, the bigger number is always on the right. Close dot, shade to the left, close dot, shade to the right. So again, this one shouldn't be that difficult, hopefully. And we're kind of going from there. Alright, final problem! Yay! Ow, jaw pop. Alright, 2z minus 2 less than or equal to 3 less than. So I'm saying 2z minus 2 less than equal to 3. And at the same time, negative 3 in between, so on and so forth. So we're going to add 2. Add 2. Add 2. You get 2z less than negative 1, 5. Divide by 2, divide by 2, divide by 2. Z, bada, negative 1 half and 5 halves, or negative 0.5 and 2.5. For those of you who dislike fractions so much because they're so scary. Nah, They're not. Y'all are just silly. All right. Shade in between, going from there, and you're done. And keep in mind that the brackets, the interval notation would have been -1/2 and 5/2. Okay. So, again, the idea here is hopefully you get to study or you look over these words and kind of go from there. You got bonus points if you do the interval notation, so I won't put in a secret word or anything like that. And then there you go. That's it. That's all for today. Hopefully y'all study and y'all watch this video and y'all will do well on the test. Thank you very much for your time. Take care.